Welcome to Ganithalai. This is Nabir Mirawali. In this video, we are going to discuss about the indefinite integration. Indefinite integration. In this one, we are going to discuss about the brief introduction and explanation of partial fractions. Okay, and finding the integration of the functions by using partial fractions. Okay, let's start the topic. Okay, let me explain them briefly the partial fractions concept. Okay, what is that? Partial fractions. Partial fractions. So partial fractions means there are two functions I have taken. Let f of x and g of x are two functions. Then a fraction f of x by g of x is said to be first one, proper fraction. What is that? Proper fraction if the condition is degree of g of x is greater than degree of f of x. That means here we have taken the two functions f of x and g of x. So whenever the degree of the denominator is greater than the degree of the numerator, then such type of functions are called the proper fractions. Okay, the example of this proper fraction means suppose 2x square minus 4x plus 5 I had taken by 3x cube minus 2. Okay, so they are the example for the proper fractions. Okay, so look at here, what is the degree of the numerator here? Degree of the numerator is 2. Next, degree of the denominator, what is that? 3. Here always the degree of the denominator is higher than the degree of the numerator. Such type of fractions are called the proper fractions. Okay, next one more example I have taken. 2x minus 5 by x plus 5 into 2x plus 4. Okay, here in this one the numerator is this one. This degree is how much? The degree of this one? 1. In the denominator here two product functions are there. In this one the first product x plus 5 having the degree 1, second product having the degree 1. Whenever we should multiplying the two polynomials, now the degree of obtained polynomial will be adding the highest degree of the two products. So that means degree of the denominator is 1 plus 1, that is the degree of the total denominator is 2. So here degree of the denominator is higher than the degree of the numerator. Okay, they are the example for the proper fractions. Okay, next one I had taken here, second one. So f of x by g of x is said to be the improper fraction. Improper fraction if degree of g of x is less than or equal to degree of f of x. Okay, that means degree of the denominator is always less than or equal to degree of the numerator. Such type of fractions are called the improper fractions. Example for improper fractions are examples. Suppose 2x cube minus 4x square minus 5 by here 2x plus 1 into 5x minus 4 I have taken. Here look at here, degree of the numerator is 3 and degree of the denominator is here the first product degree is 1, second product degree is 2. Whenever they multiplying, we will add the degrees of these two products, you will get the total degree of the polynomial. So the degree of the denominator is 1 plus 1, 2. So observe that the denominator degree is 2 and numerator degree is 3. In this one, here degree of the denominator is less than the degree of the numerator. So that means this is the example for the improper fraction. Next one more is 2x square minus 5x plus 4 by x square minus 1. Okay, this is the fraction we have taken here. What is the degree of the numerator? 2. Degree of the denominator is 2. So in this one, degree of the denominator is equal to degree of the numerator. So this is the example for the, what is that? Improper fraction. Okay, what is the improper fraction definition we had taken? If the numerator degree, denominator degree both are equal, or degree of the denominator is less than degree of the numerator, either equal or degree of denominator is less than the degree of the numerator, then we say that such type of fractions are called the improper fractions. Here partial fractions are two types here. So one is proper fraction, another one is improper fraction. Okay, now we are going to split the proper fractions only. That means we can factorize, that means we can do the factorize for the proper fractions only. So to find the improper fractions, first of all we can divide the numerator by the denominator. It will obtain into the proper fractions, and hence we can continue the process for the proper fractions. So first of all, now we are going to check whether how we are going to discuss about the proper fractions. Okay, let me explain that one. So what is that? Proper fractions. Proper fractions, we know that the proper fractions means the denominator degree is always higher than the numerator degree. Okay, suppose I have taken a proper fraction. Let f of x comma g of x are polynomials if degree of denominator, that is g of x, is greater than degree of numerator I have taken f of x. Now they are the important steps you have to take here. First of all, f of x by g of x is there. Now we can factorize always denominator. If you will get the denominator will be of the form x minus a into x minus b into x minus c. That means the denominator, if you factorize the denominator, you will get here that the denominator value, that means the denominator can be separated into the product of the linear factors. That means linear means, so degree 1. So if all are the linear different factors, then we can use that. So in the place of f of x, we can't write the f of x here. So how many factors are there here? X minus a. We can split them here. Now we have to split here x minus a. Next one, second factor x minus b. Third factor x minus c. Okay. So here simply you can write some constants a, b, c. So this is the procedure to split the given proper fractions when the denominator will be in the linear factors. So the denominator will be in the linear factors. You can split this fraction into the form of a by x minus a plus b by x minus b plus c by x minus c. So it is enough to find the value of a, b, c. Okay. Now I am going to discuss about the how to find the a value, b value, c value whenever the denominator should be distinct linear factors. Okay. So here the process I am going to explain you. So to find the a value, this is the very short method I have told you. I am going to explain you. So to find the value of a, that means capital A value, you should take the denominator of that one. That means what is the denominator here? So here the denominator is, what is that? X minus a. This can be taken as 0. After taking 0, you can put x is equal to a. Okay, so where you have to substitute x is equal to a? In the left hand side. What is that? F of x by so and so will be there. So remember one thing, whenever you have to take the x minus a is equal to 0, you can removing x minus a from the left hand side. Now the capital A value will be obtained by substituting x is equal to a from the left hand side. So you have to substitute x minus a is equal to 0 in the left hand side. Whenever you have to put x minus a is equal to 0, you can left here on the left hand side x minus a here. So you can take a minus b and a minus c. You will get the a answer. In the same process to find, this is for a. For a, you have to take x minus a is equal to 0. In the same process for b, you should take here, what is the denominator of b? X minus b. So that can be considered as 0. Now you can substitute x is equal to b from the left hand side. You will get b value. So before going to substitute x is equal to small b in the left hand side, you can remove x minus b here. Now the remaining values, what are there in the denominator? X minus a and x minus c, and numerator will be substituted into f of b by x, sorry, x means b minus a. So b minus a and c minus a, sorry, b minus a and b minus c. Okay, this is the very shortcut methods to find the a value and b value. In the same process, c also find by using this same process. Okay, this is the first concept. Okay, that means to find for a, let denominator of a, x minus a is equal to 0. Then you can substitute x is equal to a in the left hand side. You will get the answer, that is f of a by, so we have taken x minus a as 0. Now you can remove x minus a here. So now remaining values you can put x as a. Okay, now a minus b into a minus c, this is the a value. Next for b, so what is the denominator of b here? X minus b. You can take x minus b as 0. Now you can substitute x is equal to b on the left hand side. Now b will be obtained by f of b. So x value can be substituted as b. So now here you are going to substitute x is equal to b except in this one. Okay, so now what you will get here? F of b by b minus a into b minus c. Okay, in the same process for c, let the denominator of c, what is that? X minus c, that can be considered as 0. Now you can get x equal to c, that will be substitute in the left hand side value. You will get c answer by c minus a and c minus b. So don't substitute in the place of x minus c here. So you will get here the answer of capital A and capital B, capital C values. Okay, this is the procedure. Whenever the denominator can be factorized, then it will be converted into the linear factors. Now second method of fractions. Okay, suppose I have taken the given fraction f of x by g of x here. Here numerator is f of x. Whenever we have to find the denominator into partial fractions, you will get like that, x minus a into x minus b whole square. That means here one is linear factor The second one, what will be there? X minus b. This is also a linear factor, but it will repeat it twice. Okay, so multiple linear factors are there. Such kind are called multiple linear factors. So now you can write, you have to remember here, first of all you should write the linear factor. That means this is linear factor, means repeated linear factor. You can write like that, x minus a. For the multiple linear factors also you can write b by, what is the multiple linear factor first degree? How many times it will repeat it? 2 times. So that's why first you have to take x minus b, second one c by x minus b whole square. Okay, remember here student, suppose here x minus a into x minus b whole square are there in the denominator. Okay, now this x minus a is the non-repeated linear factor here, and x minus b whole square is the repeated linear factor here. So for that, x minus a you can write simply as x minus a by x minus a. For multiple linear factor, what will be there? X minus b. For that one you can start with degree 1, that is b by x minus b plus next one c by x minus b whole square. So this is the process to split this factor into this one. Okay, so now suppose if you have in the place of square cube is there, so you have to write one more thing, d by x minus b whole cube. Okay, like that the process will be continued. Okay, so here the solution procedure. So how to process here? So first, how to find the linear factors? Whenever the denominator having the linear factor, we can find like that. Okay, so first of all you have to choose where are the linear factors. So this is the linear factor we have. So in this one, here okay, here the linear factors are, what are the linear factors here? X minus a is the non-repeated linear factor. So whenever we have simplifying here, it will be a by x minus a. First we have to find the a value. So we should find out the linear non-repeated numerator values. What are the linear non-repeated numerator value? A. So first we need to find the for a value. Let x minus a is equal to 0. Hence we can substitute x is equal to a. For a value you can substitute x is equal to small a in the left hand side. What is that? In this one. But you have to remove x minus a here. Now the remaining value, in the remaining value you can substitute x is equal to a, f of a by a minus b whole square. You will get the answer. Next, what you have to find here? For next factor, what is that? X minus b. Highest power what will be there? 2 is there. So where we have written x minus b whole square, first you have to go on the right hand side. So here, so what is the numerator of that one? C. So here directly we can find c value. Here directly b value we can't find here, because of the this is x minus b is the repeated, that means multiple linear factor. Multiple means repeated linear factor. So that is, what is the highest of this one? Highest power of this linear factor, that means multiplicity. What is the multiplicity of x minus b? 2. So here we have to find only the x minus b whole square numerator value. What is the numerator of x minus b whole square value? C. So here we could find out the capital C value here. Okay, now for C, what is the denominator here? C denominator, x minus b whole square. Okay, whenever you should take x minus b whole square is equal 0, you can write x minus b is equal 0 and x is equal to b. Now you can put left hand side x is equal to b in the left hand side. Now f of b by, you have to write b minus a. Don't write x minus b. In the place of x minus b, x value as b. Okay, you can left that one. So now finally it is enough to find the b value. For finding the b value, we can take the given problem here and taking LCM on the left hand side, you can comparing the x coefficient, that means x square coefficient, x coefficient or constant. That means you have to compare the like terms on both sides. You will get two equations. By using the two equations, you can solve the b value. Okay, that is the process to find the value of this one. Okay, next one more thing is there. Suppose okay, one more thing is, if f of x by g of x is there, where g of x is given like that, some f of x by something x minus a whole to the power of something is there, 4, directly x minus a whole to the power of 4 is there. So that means here g of x, whenever we have to factorize g of x, you will get only one linear factor. It can be repeated 4 times. Now we have to write here simply as, so first a by x minus a plus b by x minus b whole square, sorry, x minus a whole square plus c by x minus a whole cube plus d by x minus 4 x minus a whole to the power of 4. Okay, they are the factors we have to write here. X minus a, here also x minus a. So this can be done by in easy way, that is, what is the highest power of the denominator? So x minus a. First of all, we have to substitute x minus a is equal to t here. After substituting, you can write here x is equal to t plus a. Okay, now you can substitute this one on the both left hand side and right hand side. You can comparing both left hand side and right hand side. You will find the capital A and capital B, capital C, capital D values. After finding them, you can finally, the answer could be get in the values in the variable t. Finally, you can substitute the t is equal to x minus a. You will get the answer. This is the very shortcut process to find the partial fractions whenever only the denominator is the linear factor and multiplicity is more than 1. Okay, so this is next one, irreducible polynomial, when the denominator is in the irreducible polynomial. Suppose f of x by g of x is there. Now here g of x is the irreducible polynomial. Irreducible polynomial means we can't find into partial fractions for denominator. Suppose that means I have taken, so whenever you have to factorize the denominator value, you can get x minus a something, next x minus b whole square something, and next one is there, you have that is some cx square plus dx plus e is there. Now you can split this fraction into like that. First you have to write the linear factors for x minus a as a by x minus a. Next one, for the multiple linear factors, you have to write b by x minus b plus c by x minus b whole square plus, for this is the irreducible polynomial. Irreducible polynomial, we can't find the linear factors for that one. That means we can't factorize that one. Such type of polynomials are called the irreducible polynomial. For that, what is the denominator degree? What is the degree of that irreducible polynomial? Square. You can reduce the power 1. That means, suppose if the degree is 3, you can take x square. If the degree is 4, you can take x cube. If the degree is 2, you can take 1. Okay, so that means I am going to take x power 1 and x power 0. That means, what is that x power 1 means x, x power 0 means constant. Okay, first of all you have to take like that and take the constant here. we are taken here a, b, c. Next I am going to continuing here dx plus e by irreducible polynomial. What is that? Cx square plus dx plus e. Okay, now we can doing here LCM of the right hand side. After that, comparing on both left hand and right hand side like term coefficients, you will get the equations and they can be solved. Okay, by solving you can find the a value, b value, c value, d value, e value. Okay, this is the procedure to find the integration of the given functions by using the partial fractions method. So to integrate the such type of functions, you have to know about the this property, that means this type, and one more, second one, this one, and third one, and fourth one. Okay, in this video these partial fractions will be explained in the simple brief way. Okay, you can take this one note, you can remember this note. Okay, and now we will continue the integration problems. Okay, let's start. Okay, one more thing we have forget, so that is whenever f of x by g of x is an improper fraction, so we have to remember here things. First we can divide f of x by g of x. Second one, and using division algorithm theorem property, dividend is equal to divisor into quotient plus remainder. Okay, in this one, what is the dividend here? Dividend is the f of x, divisor is the g of x. Okay, that is f of x is equal to, divisor means g of x, into quotient means we can get something quotient that can be taken as q of x, and remainder that can be considered as r of x. Now you can substitute f of x is equal to g of x into q of x plus r of x in the value of f of x, and after that separating the denominator for the numerator, you will get this improper fraction into proper fraction. After converting the proper fraction, you will do the before procedures. Okay, this is the procedure whenever the fraction will be the improper fraction. Okay, on before concept, this is applicable for only proper fraction. Okay, so whenever the problem will be in the improper fraction, now we are going to do this process. Okay, so let's start our integration concept. Okay, this is the problem I am going to write here. Evaluate integral 1 by 1 minus 5x plus 6x square. So this is the problem given. So look at here. So this problem will be done in another way. So already I have explained you how to do this problem in another way. So now we can conclude this problem by using the partial fraction method. So let me explain here. So first you have to check whether this is the proper fraction or improper fraction. So numerator degree is, what is that? This can be written as in polynomial way x to the power of 0. In the denominator, the variable is x, highest power is 2, so that is denominator degree is 2. Here this function having the degree, denominator degree is higher than the numerator degree, so this is the proper fraction. So in the proper fraction we have to take the denominator here and we can split into factors. We can factorize this one, that is 6x square minus 5x plus 1. So for that, so product of 6 into 1 6, and we have to take 1 here. If you dividing 6 with 2, you will get 3, and multiplying by 1 with 2, you will get 2. So what is the last sign here? Plus. If you add them, what you will get? 3 plus 2 is equal to 5. So now the factors are 3 comma 2. So now I am going to factorize like that here. 6x square, next minus 2x minus 3x plus 1. So here taking 2x common, 3x minus 1, and also minus 1 taking common, 3x minus 1. Now in these two one, here 3x minus 1 is the common value, 2x minus 1. Okay, so now the factors are 3x minus 1 and 2x minus 1. Now we have to take the given problem here, 1 by 1 minus 5x plus 6x square. So sorry, first you should take the given problem without integral. So what you have to do here, 1 by 1 minus 5x plus 6x square. So here, so the fractions are 1 by what are they? 3x minus 1 into 2x minus 1. So observe that they are the linear factors, both are. So the linear factor, when we get the linear factors, you can write 3x minus 1 upon a. So a by 3x minus 1 plus b by 2x minus 1. So you have to leave this one, so you can don't write this one here. So now here onwards you can observe that 1 by 1 minus 5x plus 6x square meaning this one. So here to find the capital A value, I have told you, so the denominator for a you have to take the denominator. What is that? 3x minus 1, that will be 0. So hence you can write x is equal to 1 by 3. Now the capital A will be obtained by deleting 3x minus 1 in this one. Now what you will get, 1 by 2x minus 1 is there. In that one you can substitute x is equal to 1 by 3. Now 1 by 2 into 1 by 3 minus 1. So 1 by, so here 2 minus 3 by 3 here. So finally you can get here 1 by minus 1 by 3. So finally minus 3. Here a is equal to minus 3. This is the a value. Next for b value, for b, what is the denominator of b? 2x minus 1. If you taken this one as 0, now x is equal to 1 by 2. Now b is equal to, you can substitute on the left hand side, b is equal, x is equal to 1 by 2 except 2x minus 1. You can left here 2x minus 1 whenever you have to find the p value. Now you can get 3 into 1 by 2 minus 1. So that is 1 by 3 by 2 minus 1. That is 1 by 3 minus 2 by 2. So you can get here 2 by 1 here finally. Now the b value is 2. B value is 2. Now this a value and b value can be substituted in this one. So in this one means this one. Okay. Now we have to write here 1 by 1 minus 5x plus 6x square. Answer should be, what is that? A by 3x minus 1. So a means what is that? Minus 3 by 3x minus 1 plus b by, b means what is that b value? B by 2x minus 1 means b value is 2. 2 by 2x minus 1. So this is the substitution of given problem. So now I am going to take the given problem correctly. What is the given problem here? Integral of 1 by 1 minus 5x plus 6x square. So therefore now integral of 1 by 1 minus 5x plus 6x square is equal to integral. So the value of this one is minus 3 by 3x minus 1 plus 2 by 2x minus 1. So first I am going to write the positive term. So 2x minus 1 plus that means minus 3 by 3x minus 1 minus 1. So this is, after that you can separate the integration here. So 2 by 2x minus 1 integral minus 3 integral 1 by 3x minus 1. Okay. Now here they are of the form here. integral 1 by ax plus b form. So what is the formula? So integral of 1 by linear factor, this one. So that means linear polynomial. So simply you can write 1 by x form, that is log of ax plus b. After completing the formula, you should write the x coefficient what will be there. Okay, a plus c. This is the formula for integral 1 by x, but here value of x is a linear. So now I am going to continue here to integral of this one 1 by ax plus b form, this one. Now I have to write log of ax plus b, that means 2x minus 1. So by what is the x coefficient here? 2. So you can write 2 here. Next one minus second term minus 3 is there, you can write 3. Integral of 1 by 3x minus 1, here also this is the linear polynomial, so you can write log of 3x minus 1. After completing the formula, you should write the x coefficient. So finally plus c is there. Now if you cancelize here, you will get this one. So log of 2x minus 1 minus log of 3x minus 1. So finally we have the logarithmic formulas. So they are log a minus log b is equal to log of a by b formula is there. Whenever you have seen the subtraction of logarithm, you can convert that function into fractions. Okay, so by using that one, so you can write log of 2x minus 1 by 3x minus 1. This is the process. Okay, this is the problem of integration by using the partial fractions. Okay, next I am going to explain one more here. Okay, look at here, this is the another problem. So first of all, you have to see the given problem carefully here. So here numerator degree is x power 0. This can be written as x power 0. Here degree is 0. In the denominator, the degree of every factor is 1. Here 1, here 1. So all are the non-repeated linear factors. So degree is 3. So degree of the denominator is 3. So denominator degree is more than the numerator degree. So hence this is the, what is that? Proper fraction. So whenever the proper fraction will be given, we have to take this one separately, x into x plus 1 into x plus 2, and making the fractions here. So first x a, second fraction what is that? X plus 1, the numerator can be taken as b. Next one, third one, x plus 2, this is c. So all are linear. To find the a value, you can take x is equal to 0 here. Okay, for a put x is equal to 0. So whenever you are going to find the a value, what is the denominator of x here? Denominator of a here, x. So it can be deleted from here. You will get 1 by x plus 1 into x plus 2. So in that one, you can substitute x is equal to 0. You will get a value, that is 1 by 0 plus 1 into 0 plus 2. So final answer is 1 by 2. So that is the value of a. What is that? 1 by 2. Next one, for b, put, what is the denominator of b? X plus 1. So you have to take x plus 1 is equal to 0. Hence x is equal to minus 1. So this value can be substituted in the left hand side except x plus 1. Okay, so what is the left hand side except x plus 1? 1 by x into x plus 2. Now you can substitute here x is equal to minus 1 in this one. You will get b value, that is 1 by minus 1 into minus 1 plus 2, that is 1 by minus 1 into 1, that is finally minus 1. Hence b is equal to minus 1. Next, for c value, what is the c denominator? X plus 2. So you have to take x plus 2 as c, 0. X plus 2 is equal to 0. Now x is equal to how much? Minus 2. Now you are going to substitute x is equal to minus 2 in the left hand side except x plus 1. Okay, so now you can substitute x is equal to 2 in 1 by x into x plus 1. You will get here C answer, that is C is equal to 1 by minus 2 into minus 2 plus 1. So finally 1 by minus 2 into minus 1, that is 1 by 2. So hence C is equal to 1 by 2. So you get all the constants of the problem here. So we are going to substitute in this one. So 1 by x into x plus 1 into x plus 2 is equal to a means what is the value of a? 1 by 2. So I am going to take 1 by 2 and x is there, plus b means minus 1 by x plus 1. Next plus c means 1 by 2 into x plus 2. So this is the value of 1 by x plus 1 into x plus 2 answer. Okay, now I am going to take the given problem here. What is the given problem? Integral 1 by x plus 1 into, therefore integral 1 by x into x plus 1 into x plus 2. If you taken this one integral, you have to substitute the value of this one, 1 by 2x minus 1 by x plus 1 plus 1 by 2 into x plus 2. So after substituting, you can expand the integration here. So 1 by 2 integral 1 by x, integral 1 by x plus 1, next one 1 by 2 integral 1 by x plus 2. So all are of the form integral 1 by x formula. Next one integral 1 by linear value. So for this integral 1 by x have the formula log of x. So for the linear you have to write log of ax plus b. After writing you have to write x coefficient. So this is the formulas you are going to use here. Now that is 1 by 2 integral 1 by x value log x minus integral 1 by x plus 1 means that is linear, that is log of x plus 1. There is no x coefficient. Next after that 1 by 2 log of x plus 2, and also here x coefficient is 1, no need to write in the denominator. So this is the final answer of this problem. Okay, now I am going to give you some problems on this model, so make them as homework. Okay, take these problems as homework. Okay, I will meet you in the next video. Thank you.